Welcome to this recording. In this recording, we're going to practice using MATLAB draw commands. MATLAB pulls on the OpenGL to draw things in 3 dimensions. So this video, we're going to practice that. First of all, if you're taking part in the class, you can go to our shared folder, ME6710. Small folder. If you're in the class, go to the share folder, ME6710. Inside there's the folder MATLAB. And in this folder, there's a few things I need to point your attention to. One is 2 example files. One's animation box, one's animation cylinder. You want to grab those. And then there's down below, there's the STL Read.m file. Grab those 3. You'll have to select them, download those files, and then I put those 3 into my current MATLAB workspace. Now, if you're not taking part of this class and you want to do the same thing, animation box and animation cylinder, that's just a box that was drawn up in a CAD program and saved as an STL. Animation cylinder is just a cylinder that's drawn up in a CAD program and saved as an STL. So these are just any STL file of any 3D body. And STL Read you can find on MATLAB Central. It's readily available. Just do it. Search in STL Read. STL Read is a MATLAB function that reads an STL file and loads all those parameters into the MATLAB workspace. So the first thing we'll do is start a new script. So I just click the new script. And we'll put a few comments. So let's call this script demo 3D animation in MATLAB. It's created by, and put your name in, and the date is June 30th. And some other, so this code, the script, provide a simple example of uploading, or what would you call it, importing a CAD model saved in STL format, then first drawing or rendering this in MATLAB, followed by animation. At this level, our animation will be kinematic. But down the road, of course, could be kinematic, could be dynamic. And by kinematic, I mean we specify motion. By dynamic, I mean we specify forces and solve for the motion. Okay, so the first thing we'll do is clear the workspace. If you like to clear your window, you can say CLC. If you like to close the graphics windows, which I do, you can say close, and you can close whichever figure is available, or just close them all. So I recommend we do those 2 things. So the first key command we need to do is we need to read in STL file and let's give it a name. So we have here 2 options. One's a box and one's a cylinder. My son drew these up for me. We'll start with the box. I think he made the box so it's got different dimensions so you can kind of see it as it moves. So we'll first need to read in the box. So let's just call ours box. And we'll say box equals STL read. So we're now using this m file as a function. It even shows up over here as a function. So STL read, and it's expecting the file, and the file is animation box .stl, but it's looking for a string. It's looking for a string to define that. So I need to make this a string. So this line will take the file animation box. This function will take all the data from that CAD model and load it into the MATLAB variable type box. Box, by the way, is a structure, and it's going to have many components. We can see that, but some of the components are going to include primarily, it'll have vertices and faces. jump over for a quick second here. So when I drew my box in CAD, you know, the box might look something like this. I could have drawn something more involved, such as a cylinder. Have both. The way CAD drawings construct all our solid models is through a collection of vertices. So for example, V1, V2, V3, V4, and so on, V5, V6, V7, I might be going back there, V8, and a collection of faces. This might be face 1, might be face 2, might be face 3, etc. The vertices will all have the format X, Y, Z values. And the faces will consist of an array, a one-dimensional array of the vertices that define the corners of the face. So for example, face 1 be 1, 2, 3, 4. Sometimes I think by default they'll close, perhaps, or maybe you need to close it. And it may be a row or a column. Now I believe STLs, well, and you can look up details on STLs. I believe STLs always work with triangles. I think they're all faces are going to by default have 3 vertices. However, you know, you could envision the process of having many. So in the typical case, I think from CAD, STL files will have faces that are composed of 3 vertices, as shown here. And we can draw any type of surface that way. So if you think about the cylinder is going to be made up of a large number of vertices all the way around the top of the cylinder. So V1, V2, all the way around to Vn, or whatever naming scheme, and then Vn plus 1, Vn plus 2, all the way around. And then the vertices are formed, or the faces then get formed on the cylinder. So that's what's important. On a large array of vertices, we'll check the format of the array. So what's imported is a large array of vertices and corresponding faces. And generally, they should come in this way. You should treat box as a structure. The structure, it's a data type. Box will be the underlying data type name. And then it'll have various fields. The fields are defined after the dot. So it'd be one field would be the vertices, so it'll be box.vertices. And that's probably going to be a, and I'm guessing this is an n by 3, meaning it's n rows for n vertices by 3 columns, the x, y, z. There should be a box.faces. And that similarly will probably be an n by 3 if our vertices are all, excuse me, if our faces all have 3 vertices. And there'll be n such faces, or m in this case, m such faces, and so on. Now that may inherit color and other options. We'll just see how that goes. All right, back to MATLAB. So we've imported the box. And so actually at this point, why don't we run the program and see what we get based on what we talked about. So we'll call it demo. What is this? Demo animation. Okay, so we've run the program, so now we have box. Let's see what's available. Box is in our workspace. We can see it's a 1-by-1 structure. Here we get box, and it tells us that it's a 12 by 3 and a 36 by 3. So that tells us that we have 36 nodes and 12 faces. And if we want to look at those, let's look at the vertices. So I'll say box.vertices. And there it gave me the various vertices. So I can see, I'm assuming these are X, Y, Z coordinates. And I can kind of reconstruct where those are going to be. Similarly, if I want to see the faces, I'd say box.faces. And This tells me that the first face connects vertex 1, 2, and 3. Second one connects 4, 5, and 6, and so on. Interesting. I wonder if these things overlap. No. Okay. So now we'll go back to our program construction, and we're getting ready to animate this thing. We could go ahead or draw this thing. We could go ahead and do it right now, but I want to do a few things first. Let's add a little more detail to this thing. So let's actually give it a color. So we're going to add an additional field to our structure, and we're going to call it face color. And we'll set that. There's a couple different formats we can use for that, but in this case, let's just give it a RGB color scheme. So if we make it all red or green, let's make it all red. Red 1, green 0, blue 0. And we can also do an edge color, so we can say box.edge color. And oh, you know what? I'm noticing on my notes, I've got different ways. It also might recognize certain color schemes. But if I make them all ones, that should be black. All zeros should be white, and then a combination between. Okay, so that's my box. Now I'm ready to draw the box. And so let's put it in figure 1. And to draw the box, I will simply use my patch command. So if I want, I can go to my help up here and look at patch. And you're welcome to do that, but you can do that on your own. I'll show you the format. So as I start to type patch, it tells me I can enter X, Y, Z, X, Y, X, Y, Z, and C. So X, Y, Z are the X, Y, Z coordinates you want to draw. C is the color. I'll also take this X data, X, Y data. I'm not quite sure on that. Notice here there's an option to enter data in the exact format that we've already talked about. So you can enter faces and vertices. And there are a number of other formats, but this is the one we want to use. So we could go into patch and say patch faces, and then our faces would be box.faces, and we would say, quote, vertices, and our variable would be box.vertices. However, MATLAB has made patch smart enough to actually recognize if it's into the structure that has the faces and vertices, it'll pull those out directly. So that's what we're going to do. So we can just simply say box. It's that easy. And this doesn't print anything to workspace, so I'm not going to put a semicolon after it. One other comment, it also, you know, when we looked at patch, it didn't show us face color, edge color, and some other formats, but there's many things, many options available, and it'll also recognize those. Okay, so at this point, we can stop doing this. So let's run this guy. And there we have a box. I'm going to, a little hard to see, but there we have a box. Let's do a few other things. I want to clear the axes, and at the moment I was just seeing an XY view, but I want to see a third view. So I'm going to say view, and I've got different views I could call, but by default, view 3 is the, view 3 is the isometric view, and then I can also define my axes. So I'm going to put labels on my X axis, so it's X label, Y label, Y, and Z label, Z. So now that I want to run, now I'm going to run this. Oops. Let's go back. You know what? I cleared the axes for some reason. I don't even know why I did that. We could put it at the beginning to clear our axis before we start, I suppose. And there we go. We've got our box, and you can see here, since we did the edge colors, I can see my faces. Here I've got a face, it's a triangle. Here I've got a face, it's a triangle. Here's a face, it's a triangle, and so on, all the way around. And this is a three-dimensional thing. I'm going to click on my rotate 3D. I can see the guy. Now it is resizing every time, so it's stretching around. I would have to fix the axis size if I want to avoid that. Let's go do that. I'm going to reset the original view. So it looks like, let's go from like a negative 20. Remember that. Oops, we had it. So axes, I think actually I need to say axis. Yeah, here we got limits on the axis. If you look at patch, it'll tell you all, the help in patch, it'll tell you all your options. Here I'm going to create limits on my axis, and it's going to go x min, x max, y min, y max, z min, z max. So if we look back at our drawing, x was like -5 to 5, z was -10 to 10, and y was in the positive direction only. So let's make our axes be like -20 to 20. That's the x. The y, let's make it 0 to 40, and the z will make -20 to 20. Notice all the axes here are the same size, a total magnitude of 40. That'll keep my perspective true. So now when I draw this, notice it's set these axes limits that I have, and so when I start moving the thing around, it's not changing scale. So this is my block. And to get back where I was, I can always take view 3. And that puts me back in my original view. Okay. Now, one other thing I noticed, I had said that we're going to have all our colors edge color. Notice our face is red. Let's play with colors again. That made sense. RGB, so we made the thing red. Let's change the color to green. And by the way, this is just defining all the faces. You could go in and define the face for create an array, a two-dimensional array, create color every face. I should make it green. I said all the colors were on. That should have made it black. I'm not quite sure why that's the case. Oh, no, because, Samuel, black is all colors or no colors? Black is no color. Yeah. I got confused. All color is white. Okay. That actually worked. So now I've changed the color to green, and I've made the lines black. Frankly, I guess you could leave the lines. To me, the lines are not as helpful. So I might just leave the lines off. Oh, maybe I get them. Maybe I get them by default. Well, maybe if that's the case, what I need to do is make the lines the same color as my edges, and I get something like this. Hard to see the edges crisply, but I don't get all those vertices. So there we have it. I will save this file back into our workspace.